Hello, everyone, and welcome to this live streaming dedicated to mastering Matplotlib, one of the most powerful and widely used data visualizing library in Python. Myself, Siddharth, and I'm thrilled to guide you through this in depth exploration of Matplotlib's capabilities. And this live is designed to cater to all learners at all levels, whether you're a beginner stepping into the world of data science or an experienced professional seeking to enhance your visualization skills. Matplotlib is a cornerstone tool for creating high quality publication ready visualizations, offering unparalleled flexibility to transform raw data into meaningful insights. And in this live stream, we'll be covering demystifying Matplotlib's vast array of plotting techniques, equipping you with the knowledge and the confidence to craft compelling visualizations for academic research and business reports. So, what can you expect from this live? So, we'll start with the fundamentals, covering all the essential plotting techniques such as line plot, scatter plots, bar charts, and histograms. These foundational techniques are critical for understanding how Matplotlib works and how it will serve as the building blocks for more complex visualizations from there. And we'll progress to intermediate topics including subplots, annotation, and custom styling, which allows you to create polished and professional figures. For those who are ready to push the boundaries, we'll dive into the advanced techniques like 3D plotting, contour maps, and stream plots. And in this live, we'll begin with a clear explanation of plotting technique, followed by step coding demonstration using example datasets generated using NumPy or using a simple list or set of collection of data. I'll highlight best practices, common pitfalls to avoid, and tips for optimizing your plots for clarity and impact. Whether you're visualizing trends in financial data, exploring scientific phenomena, or presenting insights to stakeholders, you'll learn how to tailor your visualization to suit your audience and objectives. So, let me take a moment to emphasize why mastering Matplotlib is so valuable in today's data driven world. The ability to communicate insights effectively is as important as the analytics itself. A well crafted plot can reveal patterns, highlighted outliers, and tell a story that raw numbers alone cannot perceive. Matplotlib empowers you to do that with its extensive customization options and customizability with other Python libraries such as NumPy and Pandas, even Seaborn, which is an advanced part of Matplotlib, in which you have some more feature-rich experience in Matplotlib. And then, before we dive into the technical content, a quick note for on prerequisites. Familiarity with basic Python programming will be helpful, but don't worry if you're new to Matplotlib itself. I'll explain each concept from the ground up, and if you have Python and Matplotlib installed, you're ready to follow along. For those who need assistance with setup, you have to install it from the web and install Python, and any type of IDE is advisable, and ideally is not advisable. If you're using Jupyter Notebook, then it is well off. And this series is more than just a tutorial. All right, so it's a journey into the art of data science and visualization. My goal is to inspire you to see plotting not as a core but as a creative process that unlocks the potential of your data. Over the coming sessions, from visualization, climate trends to mapping business performances, I encourage you to experiment with your own data sets to make the learning experience truly your own. To wrap up this introduction, I'd like to set the stage for what's to come, and in the live stream, we'll cover the basics of Matplotlib in the coming session and its architecture, and including how to create and customize simple plots from there to each subsequent video will be built on the previous one. and gradually introducing new techniques and challenges to keep you engaged. By the end of this live, you'll have a robust toolkit of plotting skills and the confidence to tackle any visualization tasks. And of course, this is the fundamental live stream. So for professional guidance or professional content, you can comment down below and I'll make a separate video for each of these plotting techniques and stuff. So thank you for joining me in this live, and I'm eager to share my passion for data visualization with you guys, and I can't wait to see the amazing plots you'll create. So let's get started. And if you're creating a new project or if you're creating a new program, you can go on and submit the project from the link in description box down below. You can go ahead and create a GitHub repository of your project, and then you can share that to the link in the description box down below as the form opens. And without any further ado, let's get right into the live. All right. So first we have to install Matplotlib. So Matplotlib can be easily installed using pip. So for that we need to open our terminal in our IDE, and you gotta implement this command over here. So that's pip install matplotlib. So once you do that, Matplotlib will be installed on your system. And also make sure that you have a virtual environment activated, because that's the safest way of handling pip packages, right? So now we're gonna see a very basic plotting technique, and that is called as line plot. So first we'll start with line plot and um, explore some other techniques one by one. So first, to import Matplotlib, just type import matplotlib dot pyplot as plt. All right, and then we need to create a list of collection of data. So what I'll do is, let's create an x variable. With that, I'll create a list here. So I'll create a list of 1 2 3 4 5. All right, and then y is equal to list of 2 4 6 8 and 10. All right, now it's very simple to plot line plot. So what we do here is, we need to type plt dot plot, and then we are plotting x and y data, and then we can modify, we can actually modify and customize the plotting graph, but for now I'll make sure that this is very simple. And then we'll create a legend. So what's legend anyway? So legend is like, it denotes the data, like it makes you it makes it easy to understand, which you see on graph, right? Like it will show a bit of data that that denotes what's visualized on the graph. That's what you call as legend. So plt.legend to implement legend, and then we gotta make sure that it is aligned in a grid. So plt.grid is equal to true. plt.show for make sure that the graph is being shown. Now if we run this Python script, there we go. So now we can see that we have a user warning called as no artist with label found, which means we have to define a label. And here you'll see a small box here, so that's what you call as legend. So we need to make sure that a data is entered as the label, and that will be displayed on this legend. Okay, so let's just go ahead and add a title and label for this. So what I'll do here is, first let's start with the label. So put another comma and then type label is equal to, with quotations, type linear growth. Right, so this is the label for our graph, and the color will be blue. All right, done. And then let's create label for x and y axis. So what we'll do here is, go ahead and type plt.x label, and then that will be x axis, and then plt.y label, that will be y axis. All right, now let's add a title. So plt.title, the title will be simple line plot. Alright, now let's go ahead and run this file once. There you go. So now we can see that the legend is denoted as linear growth. Alright, and then we have y-axis and x-axis as the labels, and the title for our plot, that is simple line plot. These are some basic controls over your plot, so you can actually move over your plot easily by this, and then we can zoom in and zoom out very easily like that. Alright, now let's move on to the next plot, and that is scatter plot. So scatter plot is nothing but it is like a dotted plotting technique, which means the data will be as the population, right? So it will be displayed as population, so that's what you call as scatter plot. So let's see how to do that. So for generating the scatter plot data, I'm going to use numpy. Okay, so import numpy as np. Alright, so why are we using numpy? We can just create another list, right? But scatterplot is more commonly used when you are visualizing a huge number of data, right? So in that case, let's say you have a 30 or 50 number of data which has to be visualized. You cannot denote them using list, right? So that's why we use numpy to generate random data, which is like depending on the population. So let's go ahead and type np dot random dot rand, and then we're creating 50 types of data, 50 number of data, and let's denote them by x, and then same for y. Okay, so let's copy that, paste it here, and denote them with y. Now let's go ahead and plot it. So instead of typing plt.plot, we are going to type plt.scatter. Okay, and let's type x and y, that has to be visualized, and the color is equal to red. Alright, and then s is equal to 50, and alpha is the transparency. Okay, so alpha is 0.6. Alright, and then label is equal to random plots. Alright, plt.x label, and let's create a label for x-axis, so x-axis, and then plt.y label is y-axis, and then plt.title, that will be scatter plot. Alright, and then let's create the legend, plt.legend, and then plt.show for displaying the data. Alright, so now let's go ahead and run this file. There you have it. So we have 50 number of data. This is scattered among the grid, and we have our graph which is plotted as dots, right? We have the legend and it's random plot, as we can see here. The label is random plots, and this is how you do it. Alright, so let's move on to bar plots. So bar plots is nothing but it's like the bar graphs, the regular bar graphs which we drew on schools, right? When we are studying in school, we used to draw a lot of bar graphs. So that's what you call as bar plot. So let's go ahead and create a bar plot now. So for that, what I'm going to do is we don't have to use numpy for this. Okay, so we're gonna go ahead and create a list of data. So categories is equal to, let's say category A, and category B, category C, and category D. Alright, then values is equal to 10, 20, 15, sorry, let's say 25 and 15. Alright, now what I'm going to do is we're going to go ahead and type plt.bar for bar plot. So bar categories and values, so we are entering the variable for the data which is being stored, and then color is equal to green. Alright, and for this, what I'll do is we'll go ahead and type it as bar plot. and let's go ahead and run this file. There you go. But we don't have a legend here, right? So for legend, what do we do here? It's very simple. So what we'll do is go ahead and add a label. So label is equal to, and the label will be let's say categories, or sorry, let's make it as values. Okay, so values, and then let's run this file once, and we have the legend displayed. And this is what you call as bar plot. This is a very simple um, graphing technique, so which we drew on paper, right? The next thing is histogram. So histogram is just like bar plot, but instead of having gaps like differentiating between the bars, we used to have it shrunk down into a continuous bars. Okay, so let's see how to create a histogram now. So what I'll do here is let's go ahead and remove this lines over here, and then we're gonna use numpy for this. Okay, so data is equal to np dot random dot rand n, and that will be 1000. And then let's plot a histogram. So plt dot hist, we're gonna visualize the data, and bins is equal to 30, the color is equal to purple, and then alpha is equal to 0.7. so this is the data. And then for the x variable, sorry, for the x label, what I'll do is I'll replace that with the value, and the y label will be frequency. Okay, now what we'll do here is yeah, the title. So this is a histogram. So let's go ahead and run this file. So this is what you call as histogram. So what's histogram anyway? So this is what I've said before, right? Without any gaps, we have 30 bins. So 30 bins means the 30 bars which is displayed here. So we have 30 bars here, so that's what we are visualizing as 30 bins. All right, now let's move on to the next plotting method, that is pie chart. So what's pie chart? Okay, so pie chart is the default pie chart which we used to draw in paper. So let's go ahead and create a pie chart now. So for creating a pie chart, let's use the same list like data variable, and that will be labels. So labels is equal to a, b, c, and d. All right, let's make another variable, that is sizes, 255, 130, and 245, and 210. All right, now colors is equal to, let's say, gold, light blue, and light coral, and light green. All right, then what we do is plt dot pie, and then sizes, we're gonna enter sizes, and the label will be labels, and colors will be colors. So we'll denote them by the variables which we just created, and then auto pct for the frequency that we are plotting, that is percentage 1.1 f percentage. All right, then let's make it as start angle will be, let's say, 90, so it will be starting as a perfect 90-degree angle, and it will continue plotting the other data as well. So for this we don't have to enter the x and y labels, and let's enter the title. So the title will be let's say pie chart. Okay, and we don't have to have legend here because it will be already denoted in the pie chart itself. Instead of that, let's type plt.axis, and the axis will be equal. All right, so now let's go ahead and run this. So we got unexpected keyword argument, and that is pi. Okay, here, so we got an error here. Yeah, labels, I need to enter one more s here. So now if I run this, okay, we get another thing here. So oh yeah, okay, we need to enter 2 percentage symbols. Now if we run this, okay, light coral, I have spelling mistakes here and there. There we go. We can see that this is a basic pie chart, and we can see that all the datas are denoted perfectly. This is how you create a pie chart. Let's move on to box plot. Okay, so box plot is another way of plotting in Matplotlib. So let's go ahead and create a box plot here. So box plot, for that what we need to do is we'll create the data from numpy. So data is equal to np.random dot let's say normal, and then 100 and 10 200. All right, and then we need np.random dot normal, that will be, let's say, 90 20 and 200. all right, and then let's go ahead and plot this. So plt.boxplot, that will be data, and then the data will be vertical, so what is equal to true. And then what we'll do is we'll go and create patch artist, that will be true. All right, and then let's go and create plt.xticks, and that will be 1, 2, and then the group, so group 1 and group 2. all right, then we have an extra bracket here, there we go. Then let's go and create x and y label. So we don't need an x label because we created xticks, so let's create a y label. So y label is, let's say, values, and then plt.title is box plot. all right, then plt.show. Now let's run this script, there we go. So this is the box plot. So box plot is most commonly used when you have approximate data. So like when you have data which is not precise but you have an approximate data, then in that case you can use box plot. Let's move on to violin plot. So violin plot combines box plot with a little bit of kernel density estimation. all right, so for that what we'll do is we'll go ahead and erase this stuff, but instead of erasing the data, it will be the same data which we use for box plot. So plt dot violin plot, that will be data, and then plt dot xticks is 1, 2, and then let's go ahead and type group 1 and group 2. okay, and then same for this, let's go and create y label, and for the y label same values, and then plt dot title. The title will be violin plot, and then type plt dot show. Now let's run this script. So this is violin plot. So instead of having a precise box like structure, it will be curved so that you cover a wide range of area, and that will be approximate, the same structure like box plot. Okay, now let's move on to area plot. So area plot displays quantities and quantitative data with filled areas under lines. Okay, so it is useful for showing cumulative totals over time. So when you have let's say a profit or loss table, in that case area plot will be more useful. So let's go ahead and create an area plot now. So for that, I'll go ahead and erase all these lines and type x is equal to np dot linspace, that is 0, 5 and 100. All right, so we are starting from 0 to 5, but the values will be 100. So we have 100 values, which is from 0 to 5. y1 is equal to np dot sine x, and y2 is equal to np dot cos of x, and then plt dot fill between x and y1. Color will be sky blue. Okay, this will be comma, right? And then let's type alpha will be 0.4, and then the label will be sin x, right? Same for the y-axis, the second y-axis, which is y2, and the color will be salmon, and then everything will be same. Instead for sine we'll use cos. All right, now let's type plt dot x label. X label will be x axis, and plt dot y label y axis. All right, and then plt dot title area plot, and for this we need legend, so plt dot legend, and then plt dot show. Now if we run this file, we get an area plot. All right, so this is what you call as area plot. So as you can see, it's starting from 0 to 5, and we have 100 values, right? So it will be plotting like the 100 values between 0 to 5. Let's move on to contour plot. So contour plot visualizes 3D data in 2D using contour lines. It is useful for showing levels of functions over a grid. Okay, so for that, what we'll do is we need this linspace, but with a little bit of customization. That is, instead of 0, we'll use -5. So it will be -5 to +5, and then we need same for y-axis. So copy that, and then it will be y. Yeah. So now let's go ahead and type x comma y is equal to np dot mesh grid. That will be x and y, right? Done. And then let's go ahead and create z is equal to np dot sine. That will be np dot square root. Okay, that will be x to the power of 2, which is x square, and then plus y square, so x to the power of, sorry, y to the power of 2. Now let's create a contour. So for that, let's go ahead and type plt dot contour x comma y comma z. All right, and then cmap is equal to where this. All right, Same for x label, y label, just like we had in the previous parts. X axis, plt dot label, sorry, y label is y axis. Alright, and then plt dot title, that will be contour plot. Alright, and then plt dot color bar and plt dot show. Now let's run this file. There you go. So this is what you call as contour plot. So this is actually it's a 3D data, but it will be displayed as a 2D data, right? So we can move on and see the data. We can zoom in like that. So now let's move on to filled contour plot. So filled contour plot is also just like contour plot, but it will be filled using colors instead of having just the lines, like not just the outline, but it will be filled with bars and colors. Okay, so for that what we'll do is we'll move ahead and create the filled contour plot by just having the same data. Okay, and instead of this data in this viridis, let's replace that with plasma, and then let's type the title as filled contour plot. All right, now what we'll do is let's go ahead and run this data. We get filled contour plot. Right, now what we'll do is let's move on to okay, so actually this is not filled contour data. Yeah, now this will be filled. Let's run this. There we go. So this is what you called as filled contour plot. All right, now let's move on to 3D plot, which is 3D surface plot. Okay, so 3D surface plot visualizes 3D data as a surface, which is useful for showing functions of two variables. All right, so for that what we'll do is let's go ahead and have the data, which is this one will be perfect. Yeah, and we need to import another 3D library that is called as MPL toolkits. So from MPL toolkits dot mpplot3d and import axis 3d. All right, now what we'll do is we'll go ahead and type fig is equal to np dot sign np dot square root np dot plt dot figure. Okay, and then ax is equal to fig dot add subplot. Okay, 111, that will be projection is equal to 3D. all right, and then ax dot plot surface, that will be x comma y comma z. all right, and then where do I get an error over here? Okay, and this will be c map is equal to viridis. all right, and then x label and y label, so ax dot set x label, that will be x axis, ax dot y label, that will be y axis. all right, and then ax dot set z label, and then for that it will be z axis, and then plt dot title, that will be 3D surface plot plt dot show. Right, now we should be able to have the data visualized. Okay, so let's run this. There we go. So we can see this is a 3D surface plot which can be easily dragged and viewed from all the projections, starting from up to down, and there we go. So we have the data visualized as 3D plot. All right, now let's move on to 3D scatter plot. So it's just like 3D surface plot, but instead we have the scatter plot displayed in 3D. So for that, what we'll do is we'll go ahead and use the same libraries and create x is equal to np.random.rand, that will be 50, and y is equal to np.random.rand 50, z is equal to np.random.rand, that will be 50, and fig is equal to plt dot figure, that will be enclosed, and ax is equal to fig dot add subplot, and then 111 projection is equal to 3D. All right, ax dot scatter plot, that will be x comma y comma z, and then the color will be red. All right, now let's go ahead and type ax dot set x label as x axis, and then ax dot set y label, that will be y axis, and then z, so ax dot set z label, that will be z axis. All right, now plt dot title is 3D scatter plot, 3D scatter plot. All right, now plt dot show for displaying the graph, and now if we run this, we get a 3D scatter plot. So this is a 3D scatter plot. As you can see, it is plotted as scatter plot and it is being displayed in 3D. All right, now let's move to 3D wireframe plot. Okay, so now let's move on to 3D wireframe plot. So 3D wireframe plot shows a 3D surface as a mesh of lines, and it is useful for lightweight 3D visualization. Okay, so we have polar plot, error bar plot, stacked bar plot, and we have step plot, square plot, stream plot, image plot, subplots, logarithmic plots, hex bin plots, twin axis plots, text and annotations, and yeah, so let's go and see them one by one. So for now, let's move with 3D wireframe plot. So for 3D wireframe plot, we'll create the same data from NumPy. So np.linspace -5 to 5, the data will be 50, and then y is equal to np.linspace, that will be -5 to 50. Now x comma y is equal to np dot mesh grid. Alright, that will be x comma y, and then z is equal to np dot sine and np dot square root x to the power of square root x to the power of 2 and y to the power of 2, and then figure is equal to plt dot figure and ax is equal to fig dot add subplot, that will be 1 1 1, and projection is equal to 3D. Ax dot plot 3D. Alright, we don't have to enter two brackets here. Ax dot plot wireframe, and that will be x comma y comma z, and color will be blue. Alright, and then let's go and type ax dot set x label, that will be x axis, and ax dot set y label, that will be y axis, and then ax dot set z label, that will be z axis. Alright, and then plt dot title, that will be 3D wireframe plot, and then plt dot show, just like we usually used to do. Alright, now let's go and run this file. There we go. So as you can see, the data is visualized as mesh. So once we zoom it, so now we should be able to see it is in a mesh, right? So this is what you call as 3D wireframe plot. Now let's move on to polar plot. So polar plot displays data in a circular coordinate system. It is useful for periodic or angular data. Okay, it's very simple. Watch this. So what we need to do is, let's go ahead and remove these lines and create a variable as theta is equal to np dot linspace, that will be 0 to 2 into np dot pi, that will be 100. Let's remove these extra brackets. Alright, and then r is equal to np dot sine, that will be 3 into theta, and then let's move on with plt dot polar plot, and we're gonna plot theta and r, and color is equal to purple. Now let's go ahead and create the title. Let's modify that into polar plot. Alright, so now let's run this. There we go. So this is called this is what you call as polar plot. So this is a 2D plot, but still we can see that it is in a circular coordinate system. We have x and y and z axis, but still this is a 2D plot. Alright, now let's move on to error bar plot. So error bar plot shows data points with error margins. It is useful for displaying uncertainty in measurements. Okay, so for that, what we'll need to do is we'll use np, which is numpy, for generating the array of data that can be visualized. So x is equal to np dot array, and it will be 1 2 3 and 4. Alright, and then y is equal to np.array. That will be 10, 20, 30 and 40. Alright, and now let's go and create error plot. So y error, which is yerr, is equal to np.array, and we are creating an array of, let's say, 1, 2, 3 and 4. Alright, now let's go and create an error plot. So plt dot error bar is x comma y error is equal to y error, and then fmt is equal to o minus, and then color is equal to black, and error color, which is e color, is equal to red, and cap size is 5. Same for this, we need to add the x label, which is x axis, and then plt dot y label is equal to y axis. Alright, and then plt dot title is error bar plot. Alright, plt dot show, and now we should be able to run this file. There we go. So here we can see that we have error bars as red. That will be extended from the plot which we just denoted, and the plot will itself it will be in black. Okay, let's move on to stacked bar plot. So for that we don't have to use numpy. We can create arrays and we can directly plot that data. Stacked bar plots show multiple data sets stacked on top of each other, and it is mainly useful for comparing contributions across categories. So for this we need to create categories is equal to a comma b comma c, and in this, same for the next plot, that is also a bar plot, and for that it's categories and data 2, and then the bottom will be data 1, so it will be placed in the bottom of data 1. So bottom is equal to data 1. Okay, color will be orange, and the label will be data 2. Now let's go and add x and y labels. So plt dot x label will be categories, and then plt dot y label will be values. Alright, then plt dot title will be stacked bar plot, and then plt dot legend and plt dot show. Alright, now let's run this, and there we go. So we have one bar, and that is data 1, and the data 2 is plotted on top of data 1. Alright, so it is stacked. That's what you call as stacked bar plot. Let's move to step plot. So step plot displays data as discrete steps rather than continuous lines, and it is mainly useful for showing changes at specific points. So for this we can use the simple array method instead of numpy. So what we'll do here is just go ahead and type x is equal to 1, 2, 3 and 4 and 5. Alright, and then for y it's same, but 2, 4 and 1 and 5 and 3. Alright, and plt dot step, and that will be x comma y, and where it will be in the mid, so mid, and then color is equal to green, and label is equal to step data. All right, and then plt dot x label, that will be x axis, so x axis, and then y label will be the same, so y label is equal to y axis. All right, and then plt dot title, so the title will be step plot, and then plt dot legend, and we need to align this in a grid, so plt dot grid, it will be true, and then plt dot show. All right, now if we run this, we get a step plot, okay, which is nothing but it is forming as a step, right? It will be linear, and suddenly it will go for vertical, and we get a step plot, which means it's not gradually increasing, right? So it just shows the collection of data which is pre-plotted in a certain point. All right, let's move to quiver plot, or the quiver plot, which we just which I just said few moments ago. So quiver plot displays vertical fields using arrows. It is more useful for visualizing gradients or flow fields. So for that, what we'll do is we need to use numpy for generating the data. All right, so let me show you what quiver plot is. So x comma y is equal to np dot mesh grid np dot arrange, that will be -2 to 2 and 0.5. okay, and there we go. Now what we'll do is, let's create another np dot arrange, that will be -2 comma +2 comma 0.5. all right, now u is equal to -y, and then v is equal to x, so v is equal to x, and then plt dot quiver x comma y comma u comma v, and then the color will be blue. all right, plt dot x label, that will be x axis, and then plt dot y label, that will be y axis. Plt dot title, that will be quiver plot, and then plt dot grid, that is true, and then finally plt dot show. Now if we run this, there we go. So as you can see, this is what you call as quiver plot. So all the plots are denoted in arrow marks. all right, and the next thing is stream plot. So let's move on to stream plot, and stream plot is nothing but it is used for visualizing vector fields with streamlines, and it is more useful for showing flow patterns in 2D. all right, so let's move and create the stream plot. So for this, I would like to use the same kind of data set, but instead of these numbers, I would like to replace that with 3 comma 3, same for this, -3 and +3. Instead of 0.5, I would like to have, let's say, 20. Same for this, 20. And then all these data will be the same, except instead of quiver, let's replace that with stream plot. right, x label, y label will be same, and the title, instead of quiver plot, let's replace that with stream plot. okay, now if I run this file, we get the stream plot. Okay, so index 1 is out of bounds for axis 0 1. Okay, so we get an error. P dot. Okay, so instead of arrange, let's replace that with linspace. Linspace. There we go. Now if I run this, we get, there we go. So this is what you call it as stream plot, right? So which is nothing but it's just a continuous vector fields. It's same like quiver plot, but instead we have the arrow marks connected to each other as a single line. So that's what you call it as stream plot. Okay, now let's move on to image plot. So image plot is used for displaying 2D data as a colorful grid. It is useful for visualizing matrices or images. Alright, so let's start by going and creating a data. So data is equal to np.random, that will be rand and 10 to 10. Alright, and then we create tlt.imshow, that will be data, and cmap is equal to hot, and interpolation is equal to nearest. Alright, plt.colorbar and plt.title, that will be image plot, and then plt.show. Now let's run this. So this is image plot. So as you can see, this is a pixelated image type of graph, but it's completely not an image, of course. So now let's move on to subplots, and we have logarithmic plots, hexbin plots, twin axis plots, and text and annotations inside plotting. So let's see them one by one. So first let's move on to subplots. We're about to finish our topics. So for creating subplots, what we'll do is let's create x is equal to np.linspace, and that is 0 to 5 to 100, and fig is fig and axis 1 and axis 2 is equal to plt.subplots, that will be 1 comma 2 comma fig size is equal to 10 comma 4. Alright, and then axis 1 dot plot will be x comma np dot sine, and that will be sine x comma b. Alright, and then x1 dot set title will be sine. So x2 dot plot x comma np dot sine, sorry, np dot cos. So cos of x, that will be r, and then axis 2 dot set title will be cosine, and then plt dot tight layout for just fitting everything inside, and then show. Let's run this. So as you can see, this is the subplot, which means we have two plots inside the same grid. So that's what you called as subplots. Alright, now as you can see, this is using the same set of data, but instead we have two plots plotted, but it's not in a separate window, right? So that's what you call as subplots. Let's move on to logarithmic plots. So logarithmic plots uses logarithmic scales for axis, and it is useful for data spanning multiple orders of magnitude. Okay, So for this, what we'll do is let's go ahead and remove these lines and type x is equal to log space np dot log space 0 to 5, and the number of value is 100. All right, and then y is equal to x to the power of 2 and plt dot plot, what we're plotting, x comma y, and then plt dot x scale, that will be log. All right, and same for the y scale, so plt dot y scale is log. All right, and then plt dot x label, so it will be x axis, and that will be in the log format. Same for y label. There we go. And then plt dot title, the title will be logarithmic plot. And the grid, yes, we need a grid for this, so grid is true. Then plt dot show, that will be the logarithmic plot. So let's go ahead and run this. There we go. So this is what you call as logarithmic plot. So as you can see, the data is in log format, so it's just like line plot, right? So as you can see in the first plot which we just saw, that will be the line plot, and this is logarithmic plot. There is no difference between the representation, but the only thing is it is displayed as log values, the logarithmic values. With that, let's move on to hex bin plot. So hex bin plot visualizes 2D data and its density using hexagonal bins, and it is mainly useful for large data sets to avoid overplotting. Alright, so let's say you have around 10,000 different data that has to be visualized. In that case, you can use hex bin plot. So let's move ahead and create a hex bin plot now. So first, let's go and create x and y labels. So I mean the y data. So np dot random dot rand n. Let's create 10,000. All right. Same for y. So y is equal to np dot random dot rand n 10,000. plt dot hex bin, that will be, let's say, x comma y comma grid size, that is 50, comma c map is equal to blues. Alright, and then plt dot color bar, that will be as the label is equal to count. Alright, and then plt dot x label, it will be x axis, and plt dot y label, that will be y axis, and then plt dot title is hex bin plot, and then plt dot show. Right, let's run this. There we go. So this is what you called as hex bin plot. So this is in a hexagonal representation, as you can see here, right? And there we go. So this is almost around 10,000 random spanning of plots data. With that, let's move on to twin axis plot. All right, so twin axis plot, it is useful for plotting shares, and it's like it shares the x-axis but has two y-axes. All right, and we have, and it is mainly useful for plotting two data sets with different scales. So we're gonna use numpy for generating the data, and then we're gonna plot them. And let's go and see how to create a twin axis plot. Okay, it's pretty new for me too, because I'm not too much used to these type of advanced plotting. So x is equal to np dot linspace 0 to 5, values are 100, and y1 is equal to np dot sine of x, and then y2 is equal to 100 into np dot cos of x. Figure 1 and axis 1 is equal to plt dot subplots, and then axis 1 dot plot is x comma y1 comma b minus, and then label is equal to sine, and then ax1 dot set x label, and the x label will be x axis, and then ax1 dot set y label, that will be y axis, and then okay, instead of y axis let's type sine, and then label is cosine. Alright, instead of cosine, okay, we don't actually need label tag here, I'm sorry. So for that we need the color only, the color will be B. Okay, and let's move on with axis 2. So axis 2 is equal to ax dot twin x. Okay, we are creating the twin of ax value, ax1 value. So x2 dot plot, so plotting x comma y2 comma, let's say r minus, and then label is equal to cosine. Right, ax2 dot set y label, and that will be cosine, and color is equal to r, and then plt dot title will be twin axis plot, and then plt dot show. So now if I run this, yeah, I forgot to open and close the parenthesis. Now we have twin axis plot. Alright, so as you can see, we have it cosine, and this is the sine. It will be plotted as the two y axes, but we have one x axis, right? So this is what you call as twin axis plot. Now what else is left? Text and annotations, add labels or not to specific points. Alright, so actually there's something called as text and annotations, which is nothing but we can add labels or notes to specific points. It is useful for highlighting a key feature in a plot. Alright, it's a very basic set of thing. We can do it in line plot itself. So let's go ahead and create a line plot and try to annotate it with texts. So what we'll do here is, let's go and create x is equal to 1 comma 2 comma 3 comma 4, and then y is equal to, let's say 10 comma 20 comma 25 comma 30. Alright, and then plt dot plot, that will be x comma y comma o minus, and then plt dot text, we have a text that is in 220, so this is the coordinates, and in this coordinate we are pointing point, and the font size will be 12. Alright, and then plt dot annotate, and that will be the peak point, and it is xy is equal to 325. So this is the coordinate for that. So xy text is equal to 2.5 comma 20. Alright, and let's say put another comma here. Arrow props is dict, and the face color will be black, and the shrink size will be is equal to 0.05. Alright, now plt.x label is the x-axis, and plt.y label is y-axis, and then plt.title, it will be text and annotations. plt.show, and now if I run this, there we go. So this is the peak point, and we have the point which we just marked, so 220, so it's 2 and 20. We have the point marked as point, and we have the peak point, that is 325, so 325 we have the peak point. So this is what you call it as text and annotations, and it is in a simple line plot. So thank you for watching this stream, and I hope you guys learned about Matplotlib. This will be available as a video in my channel as well, so you can see this whenever you want. You can refer this video. So if you really think that you learned something new in this video, please make sure that you have subscribed to Tech Fortitude. Make sure to like, share to whoever in need of learning Matplotlib, and comment down below what's the next video that you want guys to see, and I'll meet you guys in my next video. Until then, bye.